Okay, so this will be our first video about vectors, okay, or at least about the cross product. So when we multiply vectors, okay, so let's say that we have these two vectors, okay, we'll call it vector A and vector B. We can multiply them in several different ways. Last semester, we learned about the dot product, in which it multiplies the parts of these vectors that are parallel to each other. Okay. For this chapter, it's important for us to learn about the cross product, which actually multiplies the parts of the vectors that are perpendicular. So instead of multiplying the piece that's parallel, it's going to multiply the piece that's perpendicular. Okay. Now, the reason why this is important is so you can think of, like, we're talking about torque, in which we use the perpendicular component of the force. So that's a situation where you might use the cross product. Okay, we're also going to be talking about angular momentum, and the cross product is really important there too, because that's another situation where we're looking at scenarios in which we're multiplying perpendicular things. Okay, and so these are times when the cross product is important. Okay, and so here's the definition of the cross product. Okay, if we take the magnitude of the cross product, okay, it would be equal to the magnitude of vector A times the magnitude of vector B times the sine of the angle between them. Okay, or the cross product of A and B is equal to the magnitude of A times the magnitude of B times the sine of the angle between them times this unit vector. So like we do I, J, and K when we write vectors in unit vector notation, what this n represents is some combination of these that makes it so that this vector is perpendicular to both A and B at the same time. So this is a three-dimensional vector product. What that means is if we have vector A and vector B like this, and we find their cross product, the only vector that's perpendicular to the both of them is the vector that's pointing out of the page, coming straight towards you, or pointing into the screen, going away from you. And so those are the two solutions to the cross product. You'll get one if you multiply A first. You'll get the other if you multiply B first. Okay, and because of this, the cross product only works in 3 dimensions. Okay, the dot product works in 2 dimensions, works in 4 dimensions. Okay, works in infinite dimensions. The cross product is limited to only 3 dimensions. Okay, and in addition to having this definition of the cross product, okay, I'm actually going to show you how to do it as well, how to multiply using the cross product. Okay, so let's say we have these two vectors here, okay, vectors A and B, and what we're going to do is we're going to multiply, we're going to find A cross B, and we're going to find B cross A, okay, and I'm going to show it 2 different ways, okay. Okay, so the first way requires making a matrix, and so this will be, the way that we construct the matrix is like this. At the top row, we write just the unit vector. So I, J, K, and we're going to put them twice. So I, J, K. And then we'll have vector A, we write it twice, 3I, negative 4J, 0K. Okay, we're going to write vector B, we'll write it twice, negative 2I, 0J, 3K. Okay? And so the way that we do this is for each piece, we multiply the diagonals. Okay? And when we multiply this way, it's positive. When we multiply backwards, it's negative. So I times negative 4 times 3 is negative 12I, minus I times 0 is 0I. Okay? Plus, for J, so we did negative 4 times 3, and 0 times 0. Okay, for J, it's 0 times negative 2, or 0J, and then minus 3 times 3, so minus 9J. Okay, and then finally, for K, 3 times 0, or 0K, minus negative 4 times negative 2K. Negative 4, negative 2 makes positive 8, and so this is minus positive 8. Okay, so we simplify, get rid of the zeros. We have negative 12i minus 9j minus 8k. And this is equal to A cross B. Okay, so I want you to practice it now, and I want you to practice by finding B cross A. So after you found B cross A, basically you would have reversed the order of these, put B on top, and what you would have found is it's the other one times negative 1. So we have positive 12i plus 9j plus 8k. Okay? And so here you have done it both ways. Okay? And now I'm going to show you an alternative method using polynomial multiplication. Okay, so what I'm going to do is I'm going to make a box. I'm going to put vector A for the top of the box, so 3i minus 4j, and I'm going to put vector B on the side, so negative 2i and 3k. Alright, and then we're just going to fill in this box, and when we do, the order that we write the letters is really important. Whatever's on top is going to come first. Okay, so 3i times negative 2i will become negative 6i squared. Okay, negative 4j times negative 2i is positive 8ji. Okay, and 3k, or 3i times 3k becomes 9ik, and then finally negative 4j times 3k becomes negative 12j. Okay, and so let's write these out. We have negative 6i squared plus 8ji plus 9ik minus 12jk. Okay, and now we have to kind of resolve these into our regular unit vectors. Okay, and so here's the rule. The order they go in is I, J, K, and like before, I'm going to write it twice just to make it simpler on ourselves. Okay, and so we're going to read this left to right. Okay, and we're going to read it right to left. And when we see something appear going left to right, we're going to replace it with the missing letter, the positive version of the missing letter. If we see it going right to left, we're going to replace it with the negative version of the missing letter. So it works like this. 8ji. If I go this way, I don't see ji. If I go this way, I see ji. And so the missing letter from j and I is going to be k, and it's going to be negative k since I'm going this way. So this is negative 8k. Alright? For the 9ik, well, I don't see ik this way, I see it going back this way. So ik, alright, we're going backwards, so it's negative. The missing letter is j, so this becomes negative 9j. Okay? And then finally, this negative 12, I see jk if I read it this way, so it becomes times positive 1. And it's a negative 12 still. And then jk, the missing letter is I, so it becomes negative 12i. Alright, and finally we have this piece right here, the negative 6i squared. Well, for this one, we don't see I squared up there. So remember, like with the dot product where it was multiplying the parallel versions, and so for the dot product this is equal to 1 since I times I is a parallel. In this case we're looking for perpendicular, so things that are parallel are equal to 0. So this equal to 0. Okay, so let me reorder this so that A cross B is equal to negative 12i minus 9j minus 8k, and that should match our answer from before. Now I want you again to go ahead and try this B cross A. That means that you're going to reverse the order here, put one on the side and the other one on the top, okay, and see if you can get the opposite of this. Alright? And hopefully you ended up with 12i plus 9j plus 8k.